Today I'm going to talk about Kubernetes security. Short disclaimer, I'm not a security expert. I'm engineer at VMware. I also try to drive the local Kubernetes Kubernetes community. I have 2 kids. I like to snowboard, do stuff with my hands, except the keyboard. And I like to do barbecue. If you want to contact me, Twitter or GitHub, it's a good starting point. All right. That's what we're going to talk about today. It's about CNCF and how CNCF is presented in Bulgaria. I'm going to touch base on container security. Also, I'm going to talk about Kubernetes security, and I'm going to do a couple of demos. I don't feel brave enough today to do live demos, so they're recorded. So yeah, it will be. We'll have some time for questions during the demo. Right? What I want to do with this talk, I was invited not because I'm an engineer in VMware. I was invited because I try to drive the community. The second point is Kubernetes. It's a new good stuff, right? But there are many attacks and many risks if you have not enough experience with Kubernetes. So be careful when you install Kubernetes and start using it. I'm going to demonstrate some attacks, which are not specifically working all the time. They're more like teaching attacks to Kubernetes. And then I'm going to provide, on the way, I'm going to provide some hardening methods how to avoid this. I'm not sure how many of you in the room are experts in Kubernetes. Can you raise hands if you know what Kubernetes is? Good amount of people? Nice. How many of you feel comfortable with Kubernetes and feel experienced with Kubernetes? Right. OK, I'm scared of you guys. So those things are needed for most of you to understand what I'm going to talk about. What's Kubernetes? Some few concepts of Kubernetes, the scheduler, pods, for example, services. You should be having some understanding about Docker containers, because I'm going to show the Kubernetes installation with Docker, not with any other runtime. And some networking very briefly. Right. What's CNCF? CNCF obviously stands for Cloud Native Computing Foundation, and it's a child entity of the Linux Foundation. That organization or foundation tries to help the software vendors and the organizations using software to be cloud native. And what's supposed to mean by cloud native is there are a long list of explanations about that, but the short one is your application should be aware that it runs in the cloud. So it knows that it's in microservice and it runs in container, which should be able to communicate with other containers somehow. For some reason, I cannot see my notes over here. Anyway, the CNCF, under CNCF, we have not only Kubernetes. Kubernetes was the first project that graduated from the CNCF program. Now we have Prometheus, Envoy, and we have many others. If you're interested in other projects under the CNCF, so those projects that drive the cloud-native world, just check the landscape. It's very interesting to see a lot of companies and a lot of projects trying to drive their way to the cloud world and to help you out with your deployments or your applications that are running in the cloud. CNCF Bulgaria. We have 7 meetups already, quite successful, I would say. Mostly, we're doing them in 2 offices, in 2 companies. VMware, one of them, Limplim is the other one. We have around 550 members, which is quite good for Bulgarian community, especially in Sofia. Vladimir and Spas are the other 2 guys, which we met in Copenhagen on KubeCon and decided to do that. If you're interested in the community, please join us. We're normally recording every session that we do. We're we're looking for speakers. So if you feel comfortable speaking in front of people, like I'm tending to do right now, you can attend. You can subscribe and then send your paper, and yeah, you can come and talk. You can practice your presentation skills there. Okay. Okay. Let's go to the topic. Next, I'm going to talk about possible attacks and where normally you can attack something or you can be attacked. Right? I come from old infrastructure world, like where servers were physicals and you have data center. That's still true. So if you want to be safe from attacks, you definitely have to take care of your underlying infrastructure. So operating system, if you run, for example, on-prem, or if you run on the public cloud, you should know your images, where that comes from, or you should protect all your metadata API on your VMs running in the cloud. Next layer, I would say, it's the container itself. So there are many, many areas where you can attack all that, right? But those are just few of them. So one of the biggest issues I've faced so far is malicious image, which means you're installing some image, you run some application that comes from some repository. Are you sure what exactly you're running? Are you sure that that image is the one that you think you're running? So you should be very careful of what you're running. Sorry. Next one, it's a very interesting approach to attack. Just a second, I need water. That one works if you don't have configured properly your, for example, container runtime. You can escape the container, you can gain access to the underlying operating system and do nasty stuff. Metrics scraping, it's a common issue, or it was in previous installation of Kubernetes. I'm going to demonstrate that one, and I intentionally did it this way so I can show you up what you were able to do in the past. Now that's more or less fixed, but still you may end up with these issues. Next one, you can attack the kubelet. For those of you who doesn't know what kubelet is, that's like the main component of Kubernetes, which drives the whole thing. So as the main one, it's exposed normally to the network and can be attacked. And the last but not least, the service account tokens. Service accounts in the terms of Kubernetes are, it speaks for itself, service account. That means some account that your pods are talking to the Kubernetes API, and you should be very careful with how you treat your accounts, because those accounts normally, they have quite a good access to your Kubernetes cluster. And many others, right? The kube API, the dashboard, if for some reason you run the dashboard, and you can access the etcd and so on. So Kubernetes, container security, some tips. Those are, if you're running any type of containers, you have to make sure that you're running your containers in the least privileged way possible, which means you're not sharing, for example, the process ID namespace of the host to the container, or you're not mounting any file system from the host to the container. Those are good practices, and they make your life easier, right? Other stuff are, when you use some image to run a container from it, you have to make sure that the base image is the one that you want to use, again. So if it's secure enough, if that image is up to date and has all the latest patches, who's building that image? Do you trust that person or organization? Is it IBM or some guy somewhere who wants to break stuff down, right? Always scan your images. I'm sorry, guys, I have a timer over here which ran out. Is that all right? I spoke like 5 minutes, and that's all right. You should always scan your image for vulnerabilities, so outdated packages or malicious software. And the last one, it's signing. It's well discussed now in the community, so that's a mechanism that you can check if that image that you use, it's actually the image that you're supposed to be running, right? And again, some tip, never run your container, if possible, as root. So when you're building your container image, you can specify this one in your Docker file, and that will make sure that if you try to run your container as root, it will fail. So enforce that one. Okay. Some words about Kubernetes aspects, the security aspects. We're going to talk about RBAC, secrets, pod security policy, and we're going to demonstrate them. We're going to talk about network policies and mission controllers. The RBAC. RBAC, it's a well-known term, and Kubernetes is using it. So role-based access control. Easily explained. You have role, and that role is bind to some subject. In this case, can be a user or can be a service account. The role defines what that user or subject can do. It's not defining what is forbidden to do. It's defining just the verbs, so the actions. For example, can you list pods? Can you create new pods? Can you list namespace and so on? The role bindings, the roles are on two levels. So you have roles on namespace level, and you have roles on cluster-wide level, which are applying for objects on cluster level, like namespaces or nodes. So you have respectively the role binding for the cluster. So the account, either user account or service account, can do these verbs. As a good practice of security, set up your kube API to log every interaction with it, and then analyze that one. It can give you, first, it can give you good insight if someone is misusing the kube API, or if you have some pod that is misconfigured and is bombarding or trying to crash your kube API with requests. Here are two examples of role and role binding on your, what's that? On your left. We have a role, the role called pod reader. The role, as I said, are related to the namespace. So this one is for default namespace. That's when you have a new installation of Kubernetes, you have the default namespace which you can use to run your workloads. That one applies for resource pod, and you have the verbs, you see it, get, watch, list. On the other side, we have the binding, which in this case connects the role, which is the pod reader, to the subject chain, and that allows the subject chain, in this case, it's a user account, it's not a service account, to list and watch and get the pods in that namespace called default. The Kubernetes secrets are objects in the Kubernetes, and they're on the namespace level. They're not especially part of the security concept, but are good to treat well, right? Treat your passwords well. So in secrets, you keep your passwords or your credentials to access something, right? For example, I have put an example over here. It's for a Docker config file, which holds your token for accessing Docker.io hub to pull images from. Secrets are consumed by the pod as a file systems, so you have them either var run, whatever, and then you can read them as files. Pod security policy, it's again object on cluster level, and those policies are, in few words, they're defining if you run a pod, and that pod has some requirements, like can I run this privileged? Can I mount the file system of the host and stuff like this? The pod security policies defines your pods, how they can behave on your system. So there are a set of rules, and they say, for example, privileged true, host process ID namespace Can I mount it? Yes or no? If the policy says no, your pod will never be created on your system. To have pod security policies, they normally, in my experience, they do not come with the default installer, so you have to set it up. After that, as a tip, create your PSP's definitions before enabling the pod security policy admission controller. To be able to use them and apply them in a namespace, RBAC is helping out with this one. So if you have a service account which runs specific set of pods, this service account should be bind to the row of the pod security policy. I'm going to show that a little bit in the demo. I'm not sure if that, can you see guys this one? Yeah, good. That's a very simple pod security policy definition straight out of the Kubernetes documentation. It says privileged. As you can see, there is no namespace in there because that's applied on the cluster level, right? So that policy practically enables you to do everything. You have PSPs enabled, but if you have that policy and you have the correct bindings in your namespace, you can run any kind of pod with all the nasty stuff. Network policy is another concept which helps out to filter traffic between the pods and the outside world. So you can take it as a firewall definition. How the rules are applied by matching a label on the pod. So you have, for example, I'm going to show that in a demo in a second. You have a label, and the network policy has that label defined in it. And if the pod matches that label, the rule is applied. So you can have like incoming traffic and outgoing traffic, and you can define a number of definitions, what's allowed, and of course, what's not allowed. To have a network policy enabled, you should have your network plugin should support that. Calico and WeaveNet are two good examples of having that in place. Very, not brief, it's good enough. Network policy definition. Again, a namespace. You have the pod selector, which matches a label called row and should be having value DB, right? If you have a DB pod, which has that label, that network policy will be applied. You have the ingress and the egress definitions. So obviously with that policy, you're going to control the incoming and outgoing traffic from the pods. You have definition from the block, for example, IP block, which is allowed and specific subset of that IP block. You have namespace selector. That means these pods can talk to pods in another namespace in the same Kubernetes cluster. And yeah, and so on. And then you have the egress, so the outgoing traffic, again, to specific IP block, and then even you can specify the port. How we can say that our cluster is secure enough, and what we can do. The Center of Internet Security releases a Kubernetes benchmark, like they release a benchmark for Docker, for your operating system, and they release for Kubernetes as well. It's a very good guideline how to secure your cluster, but it's too big, right? And if you don't feel comfortable reading 200 pages and more and applying every single check and trying to figure out what's wrong, the guys from Aqua Security, they have written a tool called KubeBench, very popular on GitHub. You see 30+ contributors. I'm trying to be one of them. So I'm going to show how you can use that tool to identify possible issues in your configuration. That tool scans your, for example, your kube API installation or your kubelet setup. There are more tools to do that. Sonoboy from Heptio, Kube Audit, and KitGat, and many more. If you feel adventurous, go and try them out. Now, I'm not sure how I'm doing with the time because my timer is not working, but whatever. I have prepared 3 demos for you guys. The first one, I have intentionally configured the cluster to allow scraping unsecured ports, so we can gain some information about running ports, namespaces, and so on. Then I'm going to show misconfigured taints. So taints in the Kubernetes world means a rule which allows or disallows if you can run specific type of workloads on the master, for example. And then I'm going to demonstrate a little bit the port security policy and network policy. I have recorded that demo because, yeah, I said I'm not brave enough to do it for live. Yeah. Ooh. Sorry for that. I have a few more slides, but they're like for after reading. My personal, I'm going to do this, right? My personal analysis, how I boost my productivity, because I'm spending my day normally in kube control. So a few commands. And then I have attached a few references to external presentation and links to some other very good videos about Kubernetes security. So feel free to check them out after that. Now, I need some water, sorry. From now on, feel free to stop me and ask me questions if you have something. I'm sorry that that blinks quite a lot. Can you see the console good? Or it's too small? Too small or too good? Okay. Okay, I have recorded the demos with a tool called ASCII Nima, and I'm going to play them one by one. All that, it's in GitHub, so you can play it at home if you want. I have set it up. I have uploaded all the setup instructions and everything, so you can actually do the demos on your own and test it out. Okay. What I'm going to do first, I'm going to SSH to my master, and I'm going to show you what I have configured wrong on purpose. I have changed the authorization mode to allow. I'm sure you can see that. I'm not sure. Should I zoom a little bit? No? It's all right. Okay. Then that's the port for the kubelet, 10250, and then I have enabled the read-only port, which is for metrics from the kubelet, which gives you idea how loaded is your kubelet. So all this can give you insights of what you can get. Then I'm running the kubebench tool. It's a relatively long command. Everything is on their GitHub page, but what the kubebench is doing is mounting the etc and the var file systems. Runs is privileged, obviously. And I run the master check because I'm running this on the master node. That thing over here, I want to show out. It's the version. Right now, CIS have released a benchmark only for Kubernetes 1.11. 1.13 is on the way, but they need some time. They need contributions to do all the checks properly. I'm sorry. Okay. When you run it, it's quite fast. It just parses out some of your configuration files and checks your running configuration. I have filtered out only for fails. I don't want to see the whole list because it's too long and gives you a recommendation what you should do and so on. It will be good for the demo. But what I wanted to show you guys is this one, that I have allowed anonymous auth to my kubelet, and the other one is this one. I don't have port security policy admission controller enabled. So in the next steps, I'm going to enable it and see what we can do with this one. But let's first focus on the scraping the unsecured metrics, ports. Can you see that down there? Right. I'm not sure if that was visible enough. Come on. Yeah. Okay. I'm curling the master node on the read-only port for the metrics, and I'm saying, okay, give me all your ports, and then I'm run that through JQ, because otherwise it's one long line, which doesn't mean much. And then I want to grab for all the names. That will give you all the ports and their names, all their namespaces and their names. So without actually having access, because I run that from my local machine, not from inside the cluster, you can get access to very sensitive data, like what you're running there. The next one, it's, can you see that? Let me just run that. Again, I'm curling, again, the master, sorry. Okay, this time it's the node that I'm going to curl the master. That's the kubelet port. That's the port that normally it should be with authorization, with some certificate, and that's the port where the scheduler and the kubelet are talking to each other, and that's how the kubelet is getting instructions what to run and so on. So from that one, if you have configured it wrong, as I did it, I have always allow on the kubelet, I can still get the information that I want. In the real world, that's not true, right? There are many articles how not to do that, but for the purpose of the demo, I did it so you can get the filling if you do not pay attention on your cluster configuration, because many people are just installing it. Hey, it's cool, let's play around, and then all of a sudden that becomes production or semi-production environment, and yeah, you can have it unprotected. Okay. And again, I'm curling on that port, the node, and obviously I have less ports on this one. In the next step, I'm curling for specific port called tiller. For those of you who are not aware, tiller is the name for a pod which runs the packaging system for Kubernetes called Helm. Sorry. Because I saw it in the previous output, that means I have a Helm installation, so package manager for Kubernetes, and I have service account for this one, which normally have a very nice, from attacker point of view, privileges to the Kubernetes cluster. So let's see what I'm going to do next. I'm again curling. Yeah, sorry, I'm curling all the time. That's the node, and then I say run. That's the API of the kubelet. I say run in the kube system namespace. On that name, that's the pod name, and that's the container inside the pod. Run that command, and that command is actually showing you the certificate of the service account which is used to run the Helm or the tiller. So with this one, practically, I'll show you in the next step. If I have the certificate, I can do authorized request to the kubelet and to do some nasty stuff like running workloads. So the next step, I'm running the same thing. I'm running again command to the same pod, but this time I'm saying, okay, can you download from that repository the kube control binary? Obviously, it's downloaded. Now I'm changing the permissions to it so I can run it. And then having the kube control inside a pod, I'm running the kube control get pods from inside the tiller pod, which has a service account associated with it, and certificate, which has good privileges like to list the pods in this case. Okay, I can list the pods from different places, right? But now let's see what I'm going to do next. I'm going to say kube control, please run that image. In this case, I'm running very simple thing, Postgres, right? It's a stock image from Docker.io, but can be anything. I've downloaded the kube control from my own repo. I can do the same with the image. I can specify the image repository and download whatever I want and run inside the cluster without actually any authorization. So I'm able to get all the ports, and I can see that I have my port, my workload running on the cluster. Right, that's about demo 1. Do you have any questions, or? All right. It's either very unclear or very clear, I don't know. You tell me later. Okay. In demo 2, I'm gonna show. Yeah. All right. Okay, no questions? All right, thank you. Okay, I'm gonna create a namespace called seconf, and I'm using a tool called Kubernetes. It's like a supplementary tool of the ecosystem, which I can define in my context which namespace I'm gonna use, right? So in the next step, I'm gonna show a few actions, like I'm scanning again the master, and I'm gonna look for a specific thing, like if I have the port security policy enabled. Obviously I don't. So I'm gonna try, I'm gonna implement a few steps which are going to show you how the PSP is powerful and what we can do with them. Right? I have a simple definition of a port. For those of you who haven't seen it, it's a simple YAML file, and you have the kind and the name, and you have the image. That's the source that I want to download. That's an image that I've built for the demo. It's a very simple image, just runs endless loop with sleep. But the thing that I have in that image is a couple of clients. Like I have the Docker client, binary, I have kube control, and so on. So I'm going to apply that one and see what will happen. That's very simple stuff, right? I can apply that, and I can have it running. Now, I'm going to show you the port security policy. Oh, sorry, I fast forwarded a little bit. That's another port definition, a bit more tricky. It's the same image, but this time I say, okay, Kubernetes, mount your Docker socket from the host to inside the container. That's all right if you're gonna do stuff with the local file system, but in this case, I'm misusing the case that I don't have PSP in place. So Kubernetes by default allows me to do that. So I'm gonna run that one, and I'm gonna bash into it. So I'm gonna get shell to it and see what I can do from there. Because I have the socket in place, can you guess what I'm gonna do next? No? All right. Okay. What I've done is I've created that port, I bashed to it, and then I'm able to execute the docker ps command inside the container. And because I have the socket from the host mounted inside the container, that's the list of all ports running right now on the node. In other words, you normally shouldn't be able to do that. Because now I can run any workload that I want, or I can delete ports or containers in this case. Now, in the next demo, I'm gonna apply the port security policy and see how the cluster will behave having that security policy in place. Because the port security policy is something that you can build on later on, all running workloads are not affected by it. So you have to start over, or just set it up in the beginning and then be careful what you're doing. So again, I'm SSHing to my master, and I see that the port security policy is not enabled. Simple script that SSH to the master and replaces a string in the kube API, which says, okay, just apply not port security policy. And I'm restarting the kubelet. I don't want to wait 30 seconds to get restarted because I have new configuration. And the part that I want to see is this one. So in perfect world, when you run kubench, you should having all your checks pass. And it's, for some reason, it's obvious that you cannot always have that, right? In some cases, you should be able to run, for example, privileged containers. So you never pass that check. Some people like Spas. We have a joke about that. He claims that all his clusters are green. I don't believe that. Vladimir doesn't believe as well, so yeah. So I have the pod security policy admission controller in place, and I try to create the same pod again. That's the one that is not with the specific configuration, but just a simple pod running an image. And the message that I hope you guys can see, it's on the bottom, says, I cannot create that pod because I don't have providers which can validate your request. That means you have the PSP admission controller installed or enabled on your cluster, but you don't have any definition of PSP, so the policy, which cannot match your pod requirement. So the cluster said, no, you cannot do that. Now, I'm going to apply this pod security policy. It's called default. It's, again, very simple, straight from the Kubernetes configuration. Documentation. What defines? It's specific types of volumes that you can mount inside your pod, and some rules like, can you share the host network? Can you share the process ID namespace? True or false? So, and then on the bottom you have the cluster row. Because I'm running everything flat, I don't have much of fancy RBAC setup. I can just apply the cluster row, and I use my admin user account, so that links straight to the policy. Right, I've applied that pod security policy, and now the message is a little bit different. It's again, I cannot do that, but why? Because I've specified in the YAML that I want to mount a host path, so that's like a file system or file from the host inside the container. And by that policy, it's not allowed. I have a specific set of volumes, and host path is not one of them. So I cannot throw that very specially crafted pod of mine that can read the socket. But then someone comes to you and say, hey, we have to run privileged containers. So can you do like a special case for us? And I'm going to apply the pod security policy, which gives you privileged setup. And you can, with the role bindings, you can specify for which namespace. So namespace is like a tenant. So you can have your development team or your whatever SRE production team, and they can have different rules, what they can run in their namespaces. That security policy allows pretty much everything. So if you just want to have pod security policy enabled and be able to run any pods, that's your pod security policy. So I'm going to apply that one. And then I'm going to rerun the same pod definition with the socket. But I'm going to try it differently, and we can see what we can do from there. Okay, I'm going to show again to the pod. And I can see it again, right? And now I'm going to demonstrate something else. That's the second part of the demo, which says misuse of wrong configured taints. So as you can see in the first part, I'm getting all the rules for the master, let's say, if I can schedule any workloads or not. Obviously, I have taint. Yeah, 2 more minutes. Ooh, okay. I'll try to be fast. Okay. And then I'm going to apply the worst port ever, which in this case not only mounts the Docker socket, but mounts the process ID namespace of the host. So if I do that, now when I'm going to show to that port. Okay, because I have 2 minutes, I'm running too fast. That one has a node selector, which means I want that pod to run on the master with this node selector. But now I have taint, so my master says, okay, no, I don't want to. I cannot run any workloads on me because I have set it up like this. And then I'm removing that taint. That's a very common case. If you have a single node installation for testing, you should remove the taint. Otherwise, you cannot run any workloads on your test cluster if you install it with kubeadm, for example. And now you can see the pod is creating, and now I'm going to SSH to it. Now Docker PS doesn't work. Doesn't work because I haven't mounted the socket, but I have mounted the whole file system. So next thing that I'm going to do, I'm linking the socket, and I can do Docker PS, and that will give me the output for all containers running on the master. Then I'm going to do the nastiest thing ever. I'm going to browse the file system of the master, and I'm going to steal the administrator certificate. And from now on, you practically own the cluster. Yeah. That's about it, demo 2. Any questions? I'm not sure if I have enough time for the demo 3, so okay, cut it off. All right. Thank you, guys. Maybe some questions, maybe not. I'll be in the lobby, so thank you.
Well, thank you very much for sharing experience with Kubernetes. We have 5 minutes for questions, so there's gentlemen over here.
Hello. Oops. Orlin, thank you for the presentation. My name is Sergey. I have a question about security delivery application to Kubernetes. Do you use in your regular process Helm and Helm charts?
Yeah.
Okay. Why you don't mention about this in your presentation?
Why?
I mean about Helm chart security.
Well, yeah, because I obviously cannot fit in 40 minutes with this one if I have more.
But Docker is shining here.
I'm sorry, I can hear you very bad. What about Docker?
No. My question about Helm charts and its security.
Yeah. I think Helm owns a totally different topic, and it will be like another 40 minutes talking about Helm charts and how we can secure them. If I'm getting your question right.
Okay, I mean about Helm provenance and it's production ready or not?
Sorry,
I mean about Helm charts provenance, and my question is it production ready or not?
Is it what?
Production ready.
Helm? Yeah.
Helm chart provenance.
Yeah, definitely. We use them on production every day, and yeah.
Okay.
I'm not sure if I'm getting your question. I can hear you very bad.
Okay, thank you.
Yeah.
We have time for one more question over here.
I know you from the meetups. Yeah.
Hi, Orlin. My name is Konstantin. Thank you for good presentation. And in your presentation, you mostly talk about securing on-premise Kubernetes. But what about the cloud? As you know, many cloud providers have their own version of managed Kubernetes. So how they are secured? What cloud is more secured? Maybe some special sort of attack for cloud version of Kubernetes?
I'm not sure if I can answer the question with the whole, but I was surprised the other day. We discovered that if you install, for example, Kubernetes and you use GCE, you don't have port security policy enabled by default. So I cannot say which one is the most secure one, because I don't use managed Kubernetes installation from the cloud. I do them for my client. So
Okay.
I haven't evaluated which one is the most secure one. Yeah, maybe we can discuss that offline. I cannot answer right away. Sorry for that.
Okay, thank you.
Thank you very much,
that was
Orlin.
everything.
Fantastic
Thank you.
presentation.